Hi guys, now we're on to our last part, which is calculating the latitude and longitude. So we just finished collecting our points. We're then going to want to put the lens cap back on our theodolite, move the telescope up, and we'll just turn it off here. By holding the orange button, you'll hear one beep. It'll say off. So here on our manual, you can separately take vertical angle 1, 2, and horizontal angle, and you're going to put it in to the kind of like equation I have to make the vertical angle, well, the different angles more manageable to work with. So my first vertical angle, it's 89, 18, 49. So we'll write that. And then we'll write vertical angle 2, 90, 38, 5. And then we have my horizontal, which is 52, 31, 41. You're now going to take your calculator and you're going to add and divide and just solve each of these so that you get one kind of like degree to look at easier. We're now going to be moving on to subtracting the vertical angle 2 from horizontal angle 1. So you'll write in your vertical angle 2 up above. So that's 90.635, and you'll subtract it from your vertical angle 1, which is 89.314. And then we're going to be adding the horizontal angle 1 by the true degrees from the theodolite to the reference point to find our actual horizontal angle. So we're going to look at the horizontal angle 1, which is 52.528, and we're going to add that true degrees, which will look back, and that was 22. And then we're going to want to subtract the theodolite elevation in feet by the reference point elevation in feet to find our relative height that we were looking at. So I'll go back to theodolite elevation in feet, which it looks like it's 74.666. And then we'll look at our reference point elevation in feet, which was 50. And we're going to subtract the 2. And then we're going to take the actual vertical angle, and we are going to times it by 3.14 divided by 180, because we want to find our vertical angle in radians to then plug it into this equation to find our distance, the theodolite distance, from the manual. So we're going to take our actual vertical angle, which was the 1.321, and put it into this equation. So now we are going to plug it into the last equation. We're going to be finding the theodolite distance from the manual. So we will take the relative height in feet, which was 24.666, and we're going to take the vertical angle in radians, which was 0.023, and we're going to plug that into the equation. It's like I got 1,072.246 feet. So basically, that means that we were looking, from the theodolite, we were looking at 1,072 feet, roughly, from our whale, from land. So now we'll turn to the back, and we want to convert this to yards because on the nautical map at the bottom, there is a thing for yards. So it just makes it easier. So I'm going to plug in that number, and we're going to times it by 3. 357.415 yards. So that is pretty much all the calculations. Now you can use your nautical map to chart these 2 points. And so you go to your compass rose and you'll line up a ruler to the value of the actual horizontal angle, which basically is the horizontal angle we were looking at our whale from our reference points subtracted and stuff, or added. We'll look back. Let's see once again. Yes, added using our reference point. So we're going to go to our map, and our actual horizontal angle was 74.528. So we'll line it up in the middle, We'll look at the outer circle. We'll go to 72, 74.5. So it's probably the closest we can get. Yes, and then we're going to take our longer ruler and move it over to our point. And you're going to take your pencil at this point and you go across it. You're now going to you're going to line up your compass to the yard scale at the bottom, and you're going to set it to your theodolite distance from the mammal. So that was 357 feet, or yards. So you'll start at the yard scale, you start at 0, you go to 300. You technically need to go 57 more, so you're going to move it. You can close it, you'll start at 0. And each line working backwards is 20. So start at 0, we'll say 20, 40, and then we'll have 60, so we'll do a little bit less. So we'll start at 300 again, and it looks like we'll be there, and we'll move the compass back to 0. So then we have that. And then we start at where the theodolite is on land, on the line, and we'll make a little mark. And those 2 points now show us where we were looking at for where our whale is, or dolphin, depending. So I'll show you here. At the top, we have our theodolite, where our theodolite was, and then we have where our reference point was, and then we drew a line here out, and then we did the distance in yards and made another line, and that's where our whale is. The last step is then to find the latitude and longitude. So you can use your rulers once again. Start at the bottom and line it up, and then move it upwards to where your whale is, and then you'll make a little mark on the side. And so on the side, you're looking at 19 degrees, 45 minutes, and then you can use, at the top here, you use your marker then, and you can kind of make points of each of the marks, then move it over to see how many seconds you're looking at. And then we're going to be looking at the top. We'll have 155 for the longitude, and then 5 minutes. And for the seconds, you'll take the ruler on the side, line it up, and move it down so it's centered over your point, and then move it back so it's on the line. Make a mark, and then you're going to use, but basically you can repeat these steps 74 to 90 for further angles to locate each whale or dolphin, and you can find its latitude and longitude. But after multiple points, you'll be able to see where the mammal is moving towards. But yeah, that's the whole process, and I hope you enjoyed. And below, the manual will be placed so that you guys can follow along.